All right, so we're starting today on Intro.5. Students are already given time to work on the page. I'm going to get some student contributions here in a moment. What Dresden said was sextant and political view are categorical variables. Okay, absolutely. To get full credit on this, you all would have to identify sex and political view as the variables that can't work. But you didn't necessarily have to tell me they're categorical. You could have conversely said they're not quantitative. I would literally take either explanation. Okay, this is actually going to happen more and more as we get into the course, where my grading rubric will say, okay, well, the right answer, quote unquote, is yes, but the way in which they explain it can be variable. Okay, so a lot of my rubrics will say, did they say this right answer? In this case, sex and political view. And then the next point, assuming this is a 2-point question, will say, do they have a valid justification? Like it's literally that general because there are different styles for it. Okay. Now for the next question, okay, I'm looking for volunteers. I don't want you to give me all three though. I want you to pick one and then talk about what in the world am I saying when I say maybe it's poorly defined. So the first thing he talked about with shoe size is what I have pre-typed on the board. Okay, equal sizes for men and women are not actually equal. For example, I wear a size 12. If my wife went to a women's shoe store and bought a size 12 shoe, it would not be the same length as my shoe. Yeah. I believe it's offset by roughly 2 sizes. So if she wanted to get a shoe that was literally the same length as my shoe, she would have to buy a size 14. So finding the mean of everyone's shoe size is not actually as meaningful as you'd like it to be. One of the things you could do to make it more powerful and more representative is break up what were you talking about, a men's shoe size or women's shoe size, and maybe get 2 separate means. Okay. So what Chase pointed out is states, and he kind of said, well, does passing through them count? And that's not what I said, but that's the spirit of what I said. What I said was, what constitutes visiting a state? You know, if you're on a family trip to, say, Florida, and you drive from Maryland down to Florida, you pass through, I don't even know how many states. Have you visited those states? Does that count? Now, I'm sure many of us would probably be pretty quick to be like, no, you didn't really visit the states. You just drove through it. But there are other gray areas. What if you're flying from, say, Maryland to California and have a layover in Texas? If you're in the airport for 3 hours, now have you visited? What if the layover was 6 hours and you felt you had time to leave the airport and go get something to eat? Now have you visited the state? Like, what is that definition? So what I could do to make that question a little more clear is how many states have you visited? And then like sort of define visiting requires you spend at least 24 consecutive hours in the state, something like that. That way everybody's kind of on the same page. We've got siblings, okay? And I think it was Brian that was pointing out there was a weird thing that caught your attention about siblings. What was that? Right. Right. So what the heck is 1.5? Now, I shared with him that this is actually part of what motivated me to make this part of the note packet because this happened one year. These are not numbers that I made up. This is actually an excerpt from an earlier demographic, data pool that I had one year. And when I talked to that student, they said, well, I didn't really know how you wanted me to count my stepbrother, or maybe it was a half sibling. I think it was a half stepbrother or half brother. So it's sort of like a lot of people, I mean, my reaction to that is, I mean, I get that it's a step sibling or a half sibling, but they live with you, they're your brother, so just say 2. Why are you saying 1.5? Okay, but then people, when that led to a conversation, people were like, well, what if I have a half sibling that I've never lived with? We were raised in separate households. Do you want me to include that? So maybe what I could do to make the question more clear is I could say, how many siblings do you currently live with? Something like that. But then the problem with that is what if you have a sibling that's like off at college? Like now you're not including that person. So again, the whole point is that when people report, so I said were step siblings included, half siblings, et cetera. Like how are you going to count siblings? But again, the point here is to understand that when somebody reports a mean to you, you really have to understand the definition of the data that they were collecting. Let me jump back to the earlier example I used with the houses, okay? And I made the hypothetical that somebody claims the average new price of a house in Damascus is $400,000. Here's why that means nothing to me. Well, one of the many reasons why. When my wife and I were ready to move, I told my wife that my only requirements is I want a 2-car attached garage and some land. My definition of that was half an acre. So I don't care what you can get anything else you want, but I want a 2-car attached garage and at least half an acre. Okay. Now, her requirements were other things. Like we have 3 kids, so she wanted a minimum of 4 bedrooms. She wanted a couple other things. And I was like, I don't care, get whatever you want. But my point is, when somebody reports that the average new price of a home is $400,000, that includes townhomes that don't have much land and probably don't have an attached garage. That includes mansions that have 3 acres and a 5-car attached garage that shouldn't be included. Like that includes a lot of homes that I'm not after. The mean I'm interested in should be filtered a lot. It should be homes with an attached garage, with 4 bedrooms, with at least a half acre of land. Does that make sense? Like there's a lot of information that needs to be kind of weeded through to get to a mean that's actually useful to me. Okay. All right. Questions. All right. So again, note at the top, it says warning, the mean may mean nothing when standing alone. And this is another example. It's actually, I'm pretty sure this is a carbon copy style problem from your demographic homework. So I'm actually doing part of your homework for you today if you're paying attention, taking good notes. Okay. As part of a homework assignment, a group of AP statistics students were asked to imagine the average height of all people in a room is 50 inches and to think of 2 ways in which this may have occurred. Use the actual former student answers below to provide rough sketches of a histogram to model the distribution described. Okay, so what I've had for you is over the years when people turn in that homework, I kind of track the answers that are given. And I can kind of categorize them as this is a style of answer that I get a lot. This is another style of answer I get a lot. So these are 4 really common answers. Now, the first one could just be one person that's 50 inches tall. That is what that bar is meant to represent. There's one person 50 inches tall. If that bar was taller, so if it was like this, the room would still have an average of 50 inches, but maybe that represents there are like 10 people that were 50 inches tall. Does that make sense? So the height of the bar is kind of like the count, how many people were there. But again, they said one person 50 inches tall. Now, this is actually why in the original format of the assignment said, give me one way this could happen. And then there was one year where like the students did a really good job of communicating with each other. And half the room told me there's one person who's 50 inches tall. I was like, okay, you're being a little cheeky. I mean, you're being smart about it. Any true mathematician wants to do as little work as possible. So I added to the homework, okay, give me 2 ways. That way you couldn't just give me that. Okay, now another really common style of answer was the room is half adults and half babies or half basketball players, half little kids. This is actually what we're going to later refer to as bimodal. Your call if you want to write that down. You don't have to. That's a term that we're going to use later on in chapter 1. But this was a really common style of answer. People would describe this idea, by the way, when you draw 2 humps, make sure 2 things for me. They're equal in height and they're centered on 50. So don't draw one that's way down here, it's centered on like, 30 and the other one's only centered at 60. Like make sure they're kind of equidistant from 50 because you want to draw an image that would hypothetically have an average of 50. Okay? And by the way, again, remember that these curves, they represent bins kind of like in the first graph. This next thing is green. You don't have to write it down. I just want you to understand that what that curve actually is meant to represent is sort of the rough image of a bunch of counts of data. Okay? So it's kind of like you have one person that's that tall, you got 3 people that are that tall, 5 people that are this tall, and so on and so forth. That's what these curves are meant to represent, collections of data. Okay? All right, here's another example of a really common answer. And again, please remember the context here is, imagine I go to the neighboring room and I come back to you and I say, I measured the height of every single person in that room and the average was 50 inches. This page is meant to demonstrate to you why that tells you nothing about who's in that room. That's the point. Okay, because there's a lot of different ways that can happen. Okay, here's another example. The room is full of 3rd and 8th grade children or prepubescent people. Okay, this is what we call normal. Because another really common style of answer that I got from people is they tried to imagine, well, what type of person is typically 50 inches? And they just said, maybe that's who's in the room. Like that's what's happening. Most people are 50 inches. And it's harder and harder and harder to find people that are shorter and taller. The further away you get from 50 inches, the less often it happens. Okay, later on in chapter 1, we'll call that a normal distribution. Okay. Now, the fourth and final, like sort of super common style of answer I got, there is a super midget. I guess there was a bottle marked drink me in the room. Anyone know what movie that's referring to? What? Alice in Wonderland. So this was another really common style of answer. People would describe most of the people. Notice my giant hump is centered a little higher than 50. Okay, they'd talk about how, well, most of the people in the room are maybe a little bit taller than 50 inches, but then you got this one really short person that pulls the mean down. And vice versa. I got answers where most of the people are like 45 inches tall, but then you got this one really tall person that pulls the mean up. Okay, so that was another style of common answer. And again, the blue curves, that's all I'm really looking for you to draw, but just understand that that represents the rough shape of the underlying bins. Okay. And I want to highlight before I point out a note, these are actual former student answers. They're not from my mind. Okay. I got answers, other student contributions for part C, where the room is full of midgets, dwarves, leprechauns, gnomes, jockeys, Asian women, Filipino women, or physically disabled people with no legs. One year I had a student that was in a wheelchair, and it was her contribution to say, well, maybe everybody in the room is disabled and they don't have legs, and that's why they're all only about 50 inches tall. I said, okay. All right. So lots of different ways for this to happen is the point. Okay. So the theme for today is let's disempower the mean. Let's understand that the mean alone is basically no information. Questions? Here. All right, so I gave some students some time to work ahead of me on this problem. First contribution we got was A seems better overall. And then I compared the statistics. So I just want to be clear, if you said what Shabam said about, well, batter A has the better overall percentage, don't stop your answer there. Provide the statistics. Okay, this is an expectation on the AP exam. If you're going to use data to make an argument, which is pretty much most of the problems, you should be citing the specific data that made you say that thing. So when you say to me, A had a better overall percentage, give me the numbers that made you say that. Okay? So for batter B, it seems that batter B is better against both types of pitchers. Batter B has a better percentage against left-handed pitchers and a better percentage against right-handed pitchers. Okay? Now, I really wanted to cage you in a box before we got to part C. That's why parts A and B said just based on the percentages. Because if I was a sports agent that represented, say, batter A, I would present the overall proportion. And I would say, oh, you should definitely pay A more. A is clearly better than B. Look at their overall percentages. But if I was a sports agent that wanted to argue for batter B's case, I would do the opposite. I'd show the fragmentation. I'd say, look, batter B is better against right-handed pitchers and left-handed pitchers. So you should pay batter B more. The question, which is, it's not totally intuitive, so don't beat yourself up if this doesn't occur to you right away. But the question is, what the heck is going on? How did this happen? Okay, Dresden? So because Dresden just basically said exactly what I have typed, I wasn't planning to reveal what I had typed first. I want to kind of explain the thought process. So I'm going to reveal what I put. Okay, and again, it's pretty much right. He nailed the head right on it. Left-handed pitchers seem to be more difficult to hit against. Both batters have a higher batting percentage against right-handed pitchers. So this happens because, notice, everything I just said is green. Okay, that's sort of background like knowledge, like something that you should notice that helps you realize how to answer this question. Okay, batter B has dealt with a larger proportion of left-handed pitchers. Okay, now I'm not just using the percentages, I'm using the actual numbers. Okay, batter B had 173 at-bats, and 135 of those were against left-handed pitchers. But batter A, who had 117 at-bats, only had 35 of those were against left-handed pitchers. I would consider this to be really crappy luck for batter B. Okay, because the statistics clearly show that if you're going against a left-handed pitcher, they both have a really hard time. Both of those numbers that I just circled are much lower than these numbers. They both clearly do better against right-handed pitchers. Does this make sense? Okay, and unfortunately for batter A, well, unfortunately for batter B, I should say, batter B has gone up against way more left-handed pitchers. So batter B's average gets dragged down by that. Now, again, I kind of revealed this in an opposite order that I was planning to. So be patient with me. I'll come right back to this if you need to copy more. But I wanted to kind of give a visual breakdown of what the heck is going on. Okay? So just kind of watch the screen and be patient with me here. What we have in front of us, let me kind of bring this box over here real quick. Okay, what we have on your packet is a visual that shows batter A does worse than batter B against left-handed pitchers. Batter A also does worse against right-handed pitchers than batter B. And yet, by some weird circumstance, batter A is better than batter B overall. Okay, that's the weird thing that's happening here. Now, here's what's the explanation that I kind of tried to reveal already. There's this internal assumption that we make, which is false, that says, okay, well, if B is this good against left-handed, or excuse me, if A is that good against left-handed and A is this good against right-handed, then A's overall average should be that number that's right in the middle. That should be A's overall average, because that's the number that's perfectly between his performance against left and right-handed pitchers. Okay, that only happens if that person went up against an equal number of left and right-handed pitchers. Does that make sense? But A went up against way more right-handed pitchers. So A's average got pulled up towards the right side. Does that make sense? Now, the opposite thing is happening with B. With B, if B is this good against left-handed and this good against right-handed and had gone against an equal number of both, then B's average would be perfectly in the middle at 421. But it's not, because B had the unfortunate luck, unlike A had more right-handed pitcher experience, B got more left-handed pitcher experience. So B's average got pulled down towards the left side. Does this make sense? So the right answer, by the way, of who's better, it's not even an argument, B. B is better. I don't give a crap that A's overall average is higher. Okay, B is better against left-handed and better against right-handed. The only reason B has a worse overall average is B apparently had the bad misfortune of going up against mostly harder pitchers. Does that make sense? Okay, so again, mean, not really meaningful if all you give is that overall statistic of 37% versus 34%. Okay, anyone need more time to copy any of this? All right, so here's the deal, folks. For this particular problem, and we don't have time to go through the whole page, but I will reveal the whole page in the notes. I want to paint you a picture. I'm going to make up an answer. Let's pretend that the answer was 75 managers. Okay. If I asked you to find the average, this is how you would do it. You would say, well, they told us there were 1,000 laborers that each make $36,000. And I'm pretending, I totally made this number up, that there are 75 managers. They tell us each of those makes $62,000. Everybody with me? So this is all of the money that they pay to laborers, all of the money that they pay to managers. This is the total amount of money they pay to all of their employees. And if I asked you to find the average, you would have to divide that by the total number of employees, which would be the 1,000 laborers plus the 75 managers. Everybody with me? Okay, so this would be a pretty simple question if I gave you the number of laborers and managers and I asked you to find the mean. What makes this question difficult is that I gave you the mean and I'm asking you to reverse engineer it to figure out how many managers there were. So this is how I'd write out my formula. I would say what I know is that 1,000 people make $36,000. I don't know how many people make 62,000. But if I add all that mess together, I get total salary of all the employees. And if I divide that by the number of employees, which is the 1,000 laborers plus however many managers there are, that's going to equal the $37,000 that's given. Does this make sense? Now, if it doesn't make sense how I'm formulating that formula, I would say that's something that we'll slowly work up to. What I'm more worried about, and this is why I wanted to include this problem today, is that this is me knocking the rust off of your Algebra 1 skills. Now that I've given you this formula, could you have solved it to get 40? Because that's the correct answer. Now, I'm going to tell you that in my notes tonight, I will include a step-by-step algebra guide for how to solve this equation. Okay? But I would encourage you to try the rest of this page at some point over the weekend, probably take you less than 10 minutes, and then check the answer key to see if you did it all right. Okay? With that, we're done. All right, so I'm going to end the recording here, but again, the answer key will include this full page as well as an additional page that shows the algebra steps for solving this equation step by step. Thanks for watching. Have a good one.